Let's talk about the distance formula, and then we'll do an example, and then we'll take a break. So the distance formula in space is really nice. It looks like the distance formula in the plane, except there's an extra term attached, but it follows a pattern. So I've copied this. I got this from Google Images as well. This is a box, right? It's actually a cube, but let's pretend like it's a box, not a it's a rectangular box, not a cube. And let's say we want to find the distance between two corners on the box. The corner, say the corner down here at the lower, one of the lower edges, the left-hand lower edge beyond the screen, right? And then the distance between that point and this point, which would be the right-hand corner of the box, it's coming out of the wall, coming out of the picture. Say we want to find the distance between those 2 points. Well, we've got to coordinatize these things. Let's call this point that's beyond the screen, let's call it x naught, y naught, and z naught. Okay? Actually, you know, to be consistent with the language of your book, let's use one subscript. So how about x1, y1, and z1? And then let's call this point x2, y2, and z2. So to develop the distance formula, I'm going to think about this point down here. Everybody look up. This corner point that's in the same plane as this point x1, y1, z1. What would the coordinates of this point be? So this is a level box. It's not tilted at all. The bottom face is all the same height. Top face all the same height. So it would have the same first two coordinates, right? So x2, y2, because all we did was go from here to here. The first two coordinates haven't changed. We've gone vertically down, though, to the same z coordinate as the first point. So x2, y2, z1. Does everybody believe that? So why does that help? Well, I could then find this distance. I'll just draw it as a solid line. I could find that distance, couldn't I? Using the regular distance formula, because it's all in the same plane. Or you could think of it in terms of the Pythagorean Theorem, but that's all the distance formula is. So what does the regular distance formula tell us about the distance between these 2 points? So we'll do that part in green, so let me just point at it. What's the distance there? It's the square root of the difference between the x-coordinates squared, right? So x2 minus x1 squared plus the distance between the y-coordinates, y2 minus y1 squared. The z-coordinates are the same, so they don't contribute anything to the distance. So that's just a normal, everyday distance formula that you're used to. Does everybody buy that? Now, what would this, the edge of the box here, what would that distance be? So it goes from this, whatever this height is, to whatever this height is. What would that distance be? Z2 minus Z1. And if we complete this will be a right triangle here. If we complete the right triangle, then really what we're interested in is that distance D, right? Does everybody see the right triangle I'm talking about? So if you kind of rotated this, the triangle, two of the sides are in purple, and then this side was in green. If you make it look flat, if you rotate it around, it might look like that, right? Where we know this side in green has this distance, x2 minus x1 quantity squared, plus y2 minus y1 quantity squared. And then this side, you already told me, is just z2, the difference between the height values, z2 minus z1. And then the thing we're calling d, couldn't we just use the good old Pythagorean theorem to get d squared? So d squared would equal this guy squared plus this guy squared. Would you buy that? What happens when you square a square root? Square root's gone, so you're left with just x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then we have to add in this guy squared. So plus z2 minus z1 quantity squared. And then if we want the actual distance, what do? We just take the square root. So that d, this is your distance formula, long story short. D is going to be the square root, I'll write the square root in a second, of x2 minus x1 quantity squared plus y2 minus y1 quantity squared plus z2 minus z1 quantity squared. And you can hopefully see it really is just a direct generalization of the distance formula that we used in the plane, isn't it? Underneath the square root, we just have one more term involving the differences between the z values of the 2 points squared. So if you want to find the distance between 2 points in space, use this formula. You know, by the way, I like going like this. Delta x squared. Isn't that a nicer formula? Plus delta y squared plus delta z squared. Change in x squared plus change in y squared plus change in z squared. So you guys have taken enough calculus to know what that means, right? Square root of all that, of course. You guys have taken enough calculus to know what that means. So if you want to remember the formula that way, it's kind of a little more compact. So let's do this example and take a break. It says show that the triangle with vertices, okay, this P, Q, and R, that just stands for the labeling on the points. So point P has coordinates -2, 4, 0. Point Q has coordinates 1, 2, -1. And point R has coordinates -1, 1, and 2. So show that those points form an equilateral triangle. So if you draw the line segments between those points, you get an equilateral triangle. I'm not going to attempt to draw it at this time, but I can use the distance formula to find the relevant distances, right? So if you have any triangle, this is kind of a generic triangle. Our triangle is in space, but I'm drawing this in the plane. So P, Q, and R, if you just find the lengths of the sides and they're all the same, isn't it an equilateral triangle? Yeah. So I'm going to do one of these, and then I'll do half the class do the other one, and the other half do the other one. So I'm going to find this distance PQ. Okay. So it's like finding the length of this side PQ. So look at point P, look at point Q, apply the distance formula. So PQ, I suppose we'll use kind of an absolute value symbolism for the length of it, okay? So PQ, okay, let's think distance formula. Oh, okay, so I just take what? The difference between the x values, square it. Now, you don't want to be too slow at this, right? So I think we could do some of this in our heads, right? So it would be 1 minus a -2. What's that? So we're going to take the square root of 3 squared, right? So, okay, so 1 minus -2, 3 squared. And then what's the next one? 2 minus 4. So plus -2 squared. So that's the difference between the y coordinates squared. That's what the formula says to do, right? So 2 minus 4, that's -2, and then square it. Everybody with me? Okay, and then what's the last distance that we're going to square? Let's see, it's -1 minus 0. So how about -1 squared? All right, so what do we get there? Let's see, 9 plus 4 plus 1 underneath the square root. Root 14, maybe? Does everybody believe that? Yeah? Okay. So let's have half the class find PR, that distance, verify that it is root 14, or maybe it's not, and then it wouldn't be an equilateral triangle. And let's have half the class find QR. So this half of the class, what are you guys getting? You are getting root 14. Woo, I copied the problem down right. That's good. Oh, maybe. So you're saying that this distance from P to R is root 14 also, right? Now, you guys over there, did you get root 14? Good. Does anybody have any questions on anything? Where might you mess up here? You're going to mess up a negative at some point, right? Now, what do I mean by that? Like over here, if I had done 1 minus negative 2, and maybe I would have made the answer negative 1, that would be a common mistake, wouldn't it? Instead of forgetting, oh, minus and minus, that's that. Yeah, it's the same mistake you made in beginning algebra, but don't worry, you'll make it again at some point. That's the nice, irritating thing about math, right? You never stop making mistakes. You just make as few as possible. You get better, you make less mistakes, but you never stop making mistakes. Then I'm certainly not there yet. So don't let that frustrate you, actually. Just write down the work, be as neat as possible, and you'll make as few mistakes as possible.